Part 5 of Cosmos, a sketch of the physical description of the universe, Introduction, by Alexander von Humboldt. This LibriVox recording is in the public domain. As in nobler spheres of thought and sentiment, in philosophy, poetry, and the fine arts, the object at which we aim ought to be an inward one, an ennoblement of the intellect, so ought we likewise in our pursuit of science to strive after a knowledge of the laws and the principles of unity that pervade the vital forces of the universe. And it is by such a course that physical studies may be made subservient to the progress of industry, which is a conquest of mind over matter. By a happy connection of causes and effects, we often see the useful linked to the beautiful and the exalted. The improvement of agriculture in the hands of freemen, and on properties of a moderate extent, the flourishing state of the mechanical arts, freed from the trammels of municipal restrictions, the increased impetus imparted to commerce by the multiplied means of contact of nations with each other, are all brilliant results of the intellectual progress of mankind and of the amelioration of political institutions in which this progress is reflected. The picture presented by modern history ought to convince those who are tardy in awakening to the truth of the lesson it teaches. Nor let it be feared that the marked predilection for the study of nature and for industrial progress, which is so characteristic of the present age, should necessarily have a tendency to retard the noble exertions of the intellect in the domains of philosophy, classical history, and antiquity, or to deprive the arts by which life is embellished of the vivifying breath of imagination. Where all the germs of civilization are developed beneath the aegis of free institutions and wise legislation, there is no cause for apprehending that any one branch of knowledge should be cultivated to the prejudice of others. All afford the state precious fruits, whether they yield nourishment to man and constitute his physical wealth, or whether, more permanent in their nature, they transmit in the works of mind the glory of nations to remotest posterity. The Spartans, notwithstanding their Doric austerity, prayed the gods to grant them the beautiful with the good. I will no longer dwell upon the consideration of the influence exercised by the mathematical and physical sciences on all that appertains to the material wants of social life, for the vast extent of the course on which I am entering forbids me to insist further upon the utility of these applications. Accustomed to distant excursions, I may perhaps have erred in describing the path before us as more smooth and pleasant than it really is, for such is wont to be the practice of those who delight in guiding others to the summits of lofty mountains. They praise the view even when great part of the distant plains lie hidden by clouds, knowing that this half-transparent vapory veil imparts to the scene a certain charm from the power exercised by the imagination over the domain of the senses. In like manner, from the height occupied by the physical history of the world, all parts of the horizon will not appear equally clear and well defined. This indistinctness will not, however, be wholly owing to the present imperfect state of some of the sciences, but in part likewise to the unskillfulness of the guide who has imprudently ventured to ascend these lofty summits. The object of this introductory notice is not, however, solely to draw attention to the importance and greatness of the physical history of the universe, for in the present day these are too well understood to be contested, but likewise to prove how, without detriment to the stability of special studies, we may be enabled to generalize our ideas by concentrating them in one common focus, and thus arrive at a point of view from which all the organisms and forces of nature may be seen as one living active whole, animated by one sole impulse. Nature, as Schelling remarks in his poetic discourse on art, is not an inert mass, and to him who can comprehend her vast sublimity, she reveals herself as the creative force of the universe. Before all time, eternal, ever active, she calls to life all things, whether perishable or imperishable. By uniting under one point of view both the phenomena of our own globe and those presented in the regions of space, we embrace the limits of the science of the cosmos, and convert the physical history of the globe into the physical history of the universe, the one term being modeled upon that of the other. This science of the cosmos is not, however, to be regarded as a mere encyclopedic aggregation of the most important and general results that have been collected together from special branches of knowledge. These results are nothing more than the materials for a vast edifice, and their combination cannot constitute the physical history of the world, whose exalted part it is to show the simultaneous action and the connecting links of the forces which pervade the universe. The distribution of organic types in different climates and in different elevations, that is to say, the geography of plants and animals, differs as widely from botany and destructive zoology as geology does from mineralogy properly so called. The physical history of the universe must not, therefore, be confounded with the encyclopedias of the natural sciences, as they have hitherto been compiled, and whose title is as vague as their limits are ill-defined. In the work before us, partial facts will be considered only in relation to the whole. The higher the point of view, the greater is the necessity for a systematic mode of treating the subject in language at once animated and picturesque. But thought and language have ever been most intimately allied. If language, by its originality of structure and its native richness, can, in its delineations, interpret thought with grace and clearness, and if, by its happy flexibility, it can paint with vivid truthfulness the objects of the external world, it reacts at the same time upon thought, and animates it, as it were, with the breath of life. It is this mutual reaction which makes words more than mere signs and forms of thought, and the beneficent influence of a language is most strikingly manifested on its native soil, where it has sprung spontaneously from the minds of the people whose character it embodies. Proud of a country that seeks to concentrate her strength in intellectual unity, the writer recalls with delight the advantages he has enjoyed in being permitted to express his thoughts in his native language, and truly happy is he who, in attempting to give a lucid exposition of the great phenomena of the universe, is able to draw from the depths of a language which, through the free exercise of thought, and by the effusions of creative fancy, has for centuries past exercised so powerful an influence over the destinies of man. Limits and methods of exposition of the physical description of the universe. I have endeavored, in the preceding part of my work, to explain and illustrate by various examples how the enjoyments presented by the aspect of nature, varying as they do in the sources from whence they flow, may be multiplied and ennobled by an acquaintance with the connection of phenomena and the laws by which they are regulated. It remains, then, for me to examine the spirit of the method in which the exposition of the physical description of the universe should be conducted, and to indicate the limits of this science in accordance with the views I have acquired in the course of my studies and travels in various parts of the earth. I trust I may flatter myself with a hope that a treatise of this nature will justify the title I have ventured to adopt for my work, and exonerate me from the reproach of a presumption that would be doubly reprehensible in a scientific discussion. Before entering upon the delineation of the partial phenomena which are found to be distributed in various groups, I would consider a few general questions intimately connected together, and bearing upon the nature of our knowledge of the external world and its different relations, in all epochs of history and in all phases of intellectual advancement. Under this head will be comprised the following considerations. 1. The precise limits of the physical description of the universe, considered as a distinct science. 2. A brief enumeration of the totality of natural phenomena, presented under the form of a general delineation of nature. 3. the influence of the external world on the imagination and feelings, which has acted in modern times as a powerful impulse toward the study of natural science, by giving animation to the description of distant regions and to the delineation of natural scenery, as far as it is characterized by vegetable physiognomy and by the cultivation of exotic plants and their arrangement in well-contrasted groups. 4. The history of the contemplation of nature, or the progressive development of the idea of the cosmos, considered with reference to the historical and geographical facts that have led to the discovery of the connection of phenomena. The higher the point of view from which natural phenomena may be considered, the more necessary it is to circumscribe the science within its just limits, and to distinguish it from all other analogous or auxiliary studies. Physical cosmography is founded on the contemplation of all created things, all that exists in space, whether as substances or forces, that is, all the material beings that constitute the universe. The science which I would attempt to define presents itself, therefore, to man as the inhabitant of the earth, under a twofold form, as the earth itself and the regions of space. It is with the view of showing the actual character and the independence of the study of physical cosmography, and at the same time indicating the nature of its relations to general physics, descriptive natural history, geology, and comparative geography, that I will pause for a few moments to consider that portion of the science of the cosmos which concerns the earth. As the history of philosophy does not consist of a mere material enumeration of the philosophical views entertained in different ages, neither should the physical descriptions of the universe be a simple encyclopedic compilation of the sciences we have enumerated. The difficulty of defining the limits of intimately connected studies has been increased because for centuries it has been customary to designate various branches of empirical knowledge by terms which admit either of too wide or too limited a definition of the ideas which they were intended to convey, and are, besides, objectionable from having had a different signification in those classical languages of antiquity from which they have been borrowed. The terms physiology, physics, natural history, geology, and geography arose and were commonly used long before clear ideas were entertained of the diversity of objects embraced by these sciences, and consequently of their reciprocal limitation. Such is the influence of long habit upon language, that by one of the nations of Europe most advanced in civilization, the word physic is applied to medicine, while in a society of justly deserved universal reputation, technical chemistry, geology, and astronomy, purely experimental sciences, are comprised under the head of philosophical transactions. An attempt has often been made, and almost always in vain, to substitute new and more appropriate terms for these ancient designations, which, notwithstanding their undoubted vagueness, are now generally understood. These changes have been proposed for the most part by those who have occupied themselves with the general classification of the various branches of knowledge from the first appearance of the great encyclopedia Margarita Philosophica of Gregory Reich, prior of the Chartreuse at Freiburg toward the close of the 15th century, to Lord Bacon, and from Bacon to D'Alembert, and in recent times to an eminent physicist, André Marie Ampère. The selection of an inappropriate Greek nomenclature has perhaps been even more prejudicial to the last of these attempts than the injudicious use of binary divisions and the excessive multiplication of groups. The physical description of the world, considering the universe as an object of the external senses, does undoubtedly require the aid of general physics and of descriptive natural history, but the contemplation of all created things, which are linked together and form one whole, animated by internal forces, gives to the science we are considering a peculiar character. Physical science considers only the general properties of bodies. It is the product of abstraction, a generalization of perceptible phenomena, and even in the work in which were laid the first foundations of general physics in the 8 books on physics of Aristotle, all the phenomena of nature are considered as depending upon the primitive and vital action of one sole force, from which emanate all the movements of the universe. The terrestrial portion of physical cosmography, for which I would willingly retain the expressive designation of physical geography, treats of the distribution of magnetism in our planet with relation to its intensity and direction, but does not enter into a consideration of the laws of attraction or repulsion of the poles, or the means of eliciting either permanent or transitory electromagnetic currents. Physical geography depicts in broad outlines the even or irregular configuration of continents, the relations of superficial area, and the distribution of continental masses in the 2 hemispheres, a distribution which exercises a powerful influence on the diversity of climate and the meteorological modifications of the atmosphere. This science defines the character of mountain chains, which, having been elevated at different epochs, constitute distinct systems, whether they run in parallel lines or intersect one another; determines the mean height of continents above the level of the sea, the position of the center of gravity of their volume, and the relation of the highest summits of mountain chains to the mean elevation of their crests, or to their proximity with the seashore. It depicts the eruptive rocks as principles of movement, acting upon the sedimentary rocks by traversing, uplifting, and inclining them at various angles. It considers volcanoes, either as isolated or ranged in single or in double series, and extending their sphere of action to various distances, either by raising long and narrow lines of rocks, or by means of circles of commotion, which expand or diminish in diameter in the course of ages. This terrestrial portion of the science of the cosmos describes the strife of the liquid element with the solid land. It indicates the features possessed in common by all great rivers in the upper and lower portion of their course, and in their mode of bifurcation when their basins are unclosed, and shows us rivers breaking through the highest mountain chains, or following for a long time a course parallel to them, either at their base or at a considerable distance, where the elevation of the strata of the mountain system and the direction of their inclination correspond to the configuration of the tableland. It is only the general results of comparative orography and hydrography that belong to the science whose true limits I am desirous of determining, and not the special enumeration of the greatest elevations of our globe, of active volcanoes, of rivers, and the number of their tributaries, these details falling rather within the domain of geography, properly so called. We would here only consider phenomena in their mutual connection, and in their relations to different zones of our planet, and to its physical constitution generally. The specialties both of inorganic and organized matter, classed according to analogy of form and composition, undoubtedly constitute a most interesting branch of study, but they appertain to a sphere of ideas having no affinity with the subject of this work. The description of different countries certainly furnishes us with the most important materials for the composition of a physical geography, but the combination of these different descriptions, ranged in series, would as little give us a true image of the general conformation of the irregular surface of our globe, as a succession of all the floras of different regions would constitute that which I designate as a geography of plants. It is by subjecting isolated observations to the process of thought, and by combining and comparing them, that we are enabled to discover the relations existing in common between the climatic distribution of beings and the individuality of organic forms, in the morphology or descriptive natural history of plants and animals. And it is by induction that we are led to comprehend numerical laws, the proportion of natural families to the whole number of species, and to designate the latitude or geographical position of the zones in whose planes each organic form attains the maximum of its development. Considerations of this nature, by their tendency to generalization, impress a nobler character on the physical description of the globe, and enable us to understand how the aspect of the scenery, that is to say, the impression produced upon the mind by the physiognomy of the vegetation, depends upon the local distribution, the number and the luxuriance of growth of the vegetable forms predominating in the general mass. The catalogues of organized beings, to which was formerly given the pompous title of systems of nature, present us with an admirably connected arrangement by analogies of structure, either in the perfected development of these beings, or in the different phases which, in accordance with the views of a spiral evolution, affect in vegetables the leaves, bracts, calyx, corolla, and fructifying organs, and in animals, with more or less symmetrical regularity, the cellular and fibrous tissues, and their perfect, or but obscurely developed articulations. But these pretended systems of nature, however ingenious their mode of classification may be, do not show us organic beings as they are distributed in groups throughout our planet, according to their different relations of latitude and elevation above the level of the sea, and to climatic influences, which are owing to general and often very remote causes. The ultimate aim of physical geography is, however, as we have already said, to recognize unity in the vast diversity of phenomena, and by the exercise of thought and the combination of observations, to discern the constancy of phenomena in the midst of apparent changes. In the exposition of the terrestrial portion of the cosmos, it will occasionally be necessary to descend to very special facts, but this will only be in order to recall the connection existing between the actual distribution of organic beings over the globe and the laws of ideal classification by natural families, analogy of internal organization, and progressive evolution. It follows from these discussions on the limits of the various sciences, and more particularly from the distinction which must necessarily be made between descriptive botany, morphology of vegetables, and the geography of plants, that in the physical history of the globe, the innumerable multitude of organized bodies which embellish creation are considered rather according to zones of habitation or stations, and to different inflected isothermal bands, than with reference to the principles of gradation in the development of internal organism. Notwithstanding this, botany and zoology, which constitute the descriptive natural history of all organized beings, are the fruitful sources whence we draw the materials necessary to give a solid basis to the study of the mutual relations and connection of phenomena. We will here subjoin one important observation by way of elucidating the connection of which we have spoken. The first general glance over the vegetation of a vast extent of a continent shows us forms the most dissimilar: graminae and orchidae, conifers and oaks, in local approximation to one another, while natural families and genera, instead of being locally associated, are dispersed as if by chance. This dispersion is, however, only apparent. The physical description of the globe teaches us that vegetation everywhere presents numerically constant relations in the development of its forms and types; that in the same climates the species which are wanting in one country are replaced in a neighboring one by other species of the same family; and that this law of substitution, which seems to depend upon some inherent mysteries of the organism, considered with reference to its origin, maintains in contiguous regions a numerical relation between the species of various great families and the general mass of the phanerogamic plants constituting the two floras. We thus find a principle of unity and a primitive plan of distribution revealed in the multiplicity of the distinct organizations by which these regions are occupied. And we also discover in each zone, and diversified according to the families of plants, a slow but continuous action on the aerial ocean, depending upon the influence of light, the primary condition of all organic vitality, on the solid and liquid surface of our planet. It might be said, in accordance with a beautiful expression of Lavoisier, that the ancient marvel of the myth of Prometheus was incessantly renewed before our eyes. If we extend the course which we have proposed, following in the exposition of the physical description of the earth to the sidereal part of the science of the cosmos, the delineation of the regions of space and the bodies by which they are occupied, we shall find our task simplified in no common degree. If, according to ancient but unphilosophical forms of nomenclature, we would distinguish between physics, that is to say, general considerations on the essence of matter, and the forces by which it is actuated, and chemistry, which treats of the nature of substances, their elementary composition, and those attractions that are not determined solely by the relations of mass, we must admit that the description of the earth comprises at once physical and chemical actions. In addition to gravitation, which must be considered as a primitive force in nature, we observe that attractions of another kind are at work around us, both in the interior of our planet and on its surface. These forces, to which we apply the term chemical affinity, act upon molecules in contact or at infinitely minute distances from one another, and which, being differently modified by electricity, heat, condensation in porous bodies, or by the contact of an intermediate substance, animate equally the inorganic world and animal and vegetable tissues. If we accept the small asteroids, which appear to us under the forms of aerolites and shooting stars, the regions of space have hitherto presented to our direct observation physical phenomena alone, and in the case of these we know only with certainty the effects depending upon the quantitative relations of matter or the distribution of masses. The phenomena of the regions of space may consequently be considered as influenced by simple dynamical laws, the laws of motion. End of Part 5.